from the Martian surface to its low orbit in a reusable single-stage vehicle, Charon. In this short presentation, our goal is to offer you a quick summary of the research and conclusion. Please follow the links to review the research in further details. With Mars colonization becoming a reality in the near future, it is of importance to analyze how crew and cargo can be transported between Earth and a colony on Mars. This article is a feasibility and design study of a launch vehicle whose mission is to shuttle crew and cargo from low Mars orbit to a colony on the Martian surface. A single-stage reusable rocket has been selected to fulfill this mission, codenamed Charon. The mission profile of such a vehicle was created, leading to a maximum growth allowance, or MGA, Delta Phi budget of 6.2 kilometers per second. With the mission profile in mind, each subsystem underwent a preliminary design. With reliability and maintainability in mind, subsystems were designed for redundancy and modularity, and an abort system was included for an added level of safety. The iterative design process resulted in a vehicle with a MGA mass of 198.7 tons, capable of transporting 1,200 kilograms of cargo and a crew of 6 people to a 500-kilometer orbit and back. The preliminary designs of the vehicle is deemed safe. Following a fault tree analysis, the single launch loss of mission, vehicle, and crew probabilities are computed to be of 0.975%, 0.12%, and 0.079%. Finally, from the vehicle's constraints on the base, the feasibility of the project has been reflected upon. It is concluded that Charon is a reliable and sustainable vehicle for the given mission purpose of transporting crew and cargo between the surface and a low orbit node, promoting autonomy in the operations of a Mars colony. The program for its development and deployment is technologically and financially feasible. However, it is a vehicle that requires significant prior infrastructure on Mars. This infrastructure is unlikely to be present by 2040. Development and Mars habitats, mining, and manufacturing technologies are possible to complete within this time. However, the deployment of this equipment to Mars is likely to be too costly for a time frame of 2 decades, between 2020 and 2040. Operations are thus unrealistic expected by 2040 and more likely starting around 2050. Considerable infrastructure is necessary on the red planet for such a vehicle to operate. This vehicle is thus deemed to be practical for operations only after a sufficiently developed colony has already been established on Mars.